Now we're going to talk about how we graph them. So we're going to start with the circle. We have our basic unit circle, x squared plus y squared equals 1. That's saying my center is at 0, 0, and my radius is 1. So everywhere, and we've talked about the unit circle before. Not that we're going to worry about any of that stuff. I know some of you got scared when I said that. All right, so looking at standard form, if we want to move it right and left and up and down, this is our general standard form for every circle. X minus h squared plus y minus k squared equals r squared, where hk is the center of the circle and r is the radius of the circle. So let's look at the first example. X plus 2 quantity squared plus y minus 3 squared equals 49. So our center would be -2, +3. The signs always switch because it's always minus h minus k. And our radius is 7. So if I wanted to sketch that, I could just go out -2, 1, 2, 3, put a dot, and then count 7 places over. I'm not so great at drawing circles, so you don't have to be either. 1, 2, 3, 4, 5, 6, 7. And count 7 down here. So if I'm at 3, I'd be at -4. Count 7 up here, so I'd be at 10. I'm going to kind of run into stuff. And if I'm at -2, count 7 over here, I'd be at -9. And then just connect all your dots here. And I'm kind of out of scale, so don't even pretend that's a very nice circle. I'm not going to even worry about it. All right, let's do another one here. The idea is we're moving from a circle to an ellipse. So my center is hk, and my radius is r. That's our general equation of a circle. We can change it by taking this side over here, dividing both sides by r squared. And then if the top is squared and the bottom is squared, I can write it as x minus h over r squared plus y minus k over r squared, and this side equals 1. And the reason why I'm writing it like this is because when we look at the ellipse, this is what it looks like. So with the circle, the r is the same. So the radius on the x-axis, so when we go out in the x direction, we went 7 this way and we went 7 this way. And the radius on the r, or for the y-axis, we went 7 up and 7 down. So if you're doing the same thing, it's a circle. Where the ellipse is different, it's just saying it doesn't have to be just the radius. These two do not have to be equal. So our center is still the same. Our center is still hk. But A is the horizontal radius and B is the vertical radius. Okay, so let's look at an example of that. So if you're looking at x over 3 quantity squared plus y over 4 quantity squared, you don't see an hk, so I know my center is at 0, 0. Okay, this is my radius on the x-axis, and this is my radius on the y-axis. Okay, we have a couple of vocab words, major axis and minor axis. The major axis is just the bigger one. And the minor axis is just the smaller one. So if your radius for your y is 4 and your radius for your x, then your major axis is the y-axis, which is 8 units long because the radius is 4, so the whole axis would be 8. And the, sorry, I put that in the wrong spot. That would be, the major axis would be the y-axis, which is 8 units long. Because we're looking, when we're talking about axis, we're really looking for the diameter, basically. And so the minor axis would be the x-axis, and it is going to be 6 units long. Okay, come back to the idea of vertices because we have major vertices and minor, but let's graph this. So you start out with the center, which is 0, 0. And then this just tells me go 3 units in the x. So 1, 2, 3, put a dot. 1, 2, 3, put a dot. The y wants you to go 4. So 1, 2, 3, 4, put a dot. 1, 2, 3, 4, put a dot. So these are the vertices. So this is the point 3, 0. This is the point 0, negative 4. This is the point negative 3, 0. And this is the point 0, 4. And then you're just supposed to graph this as ellipse-ish as you can make it. And again, I am not the best drawer of these shapes, so please bear with my ugly drawings. All right, let's try one more. Okay, this one's shifted. So my center is 1, negative 2. Remember, they switch signs. Okay, and so I start there. So 1, negative 2, and I put a dot. This is my x-axis. So I go 3, 1, 2, 3. 1, 2, 3. Put a dot. Both directions, right and left. And then again, just like the last one, I go up 4. 1, 2, 3, 4. Always starting from the center. 1, 2, 3, 4. And then we just connect that. Try not to make it look like a football, real pointy on those ends. I know mine aren't the best, but try to make it more ellipsy looking. Like my vocab today, ellipsy. Anyways, so that would kind of be what it looks like. All right, now moving away from what the, given the equation, graph it, let's get the graph and write the equation. So we got to find the center. So I'm trying to find the center here, and I look to see that's the center. And that point is 1, 2, 3, 4, negative 1. Okay, and then I can see it went 1, 2, 3 units this way, 1, 2, 3 units this way, 1, 2, 3 units this way, and 1, 2, 3 units that way. So I know it's a center because it went up 3 units, down 3 units, right 3 units, left 3 units. All right, so we have a nice circle. Now, you can either use the circle equation or you can use the ellipse equation. We don't care. So when you do this, you have x minus your h plus, because it's a circle or an ellipse, y minus your k value, so minus and negative really turns it to plus, equals your radius squared. So if you're using the circle equation, it looks like this. If you're using the ellipse equation, you say, okay, my x is moved over 4 units. And my x-axis is 1, 2, 3, or x radius is 3, so I put 3 here, and I square it. And my y is moved down a unit, so minus a negative 1. And the y radius is 1, 2, 3. And then it's always equal to 1 if you're going to use the ellipse form. So either one of those are acceptable answers for that graph. All right, let's do one more here. Okay, this one looks a bit like an ellipse to me. This looks to be the center here. And I can see that it went 1 unit this direction, 1 unit this way, 2 units here, 2 units here. So it is the center. And that happens at 1, 2, 3, so negative 3, 1. And so when I write my equation, my x is being moved over to the left 3, so it's minus a negative, so it turns to plus 3. And then my axis, my x-axis, it went right and left 1 unit, so I just divide it by 1 squared. It's an ellipse, so it's plus. And then I say, okay, my y has been moved up 1, so minus 1. and the radius for the y-axis is 2, so I put it over 2, and it will always equal 1, and you're done. Now you could rewrite this, but this is fine, and we'll work on different forms in other lessons. But for now, we're good. I hope this is enough for you, and we will work on more problems tomorrow. Have a nice night.